Look up at the night sky. What do you see? A sea of twinkling stars, a canvas of cosmic wonder. Each point of light represents a distant sun, many much larger and brighter than our own. These stars, scattered across the vast expanse of space, are the building blocks of galaxies, colossal structures that house billions upon billions of stars. Our own galaxy, the Milky Way, is just one of countless galaxies in the observable universe. Imagine traveling at the speed of light, the fastest speed possible. It would take you over 4 years to reach the nearest star system, Alpha Centauri. To cross our galaxy from edge to edge would take a staggering 100,000 years. And yet, this is just a tiny fraction of the universe's size. The observable universe, the part we can see from Earth, is estimated to be over 90 billion light-years in diameter. The universe is not just vast, it's also incredibly ancient. Scientists estimate its age to be around 13.8 billion years old. The universe is a dynamic and ever-changing place, filled with mysteries waiting to be unraveled. Through the lens of science, we can begin to comprehend the intricate workings of this cosmic ballet and our place within it. Stars, those distant suns that illuminate the cosmos, are not eternal entities. They are born, they live, and they die, often in spectacular fashion. Their birthplaces are vast cold clouds of gas and dust known as nebulae. These nebulae, often remnants of previous generations of stars, serve as the cosmic nurseries for new stars to form. As clouds of gas and dust collapse under their own gravity, they begin to spin and heat up. The core of the collapsing cloud becomes denser and hotter, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This process, where hydrogen atoms fuse to form helium, releases an immense amount of energy, marking the birth of a star. Massive stars burn brightly and die young, often ending their lives in supernova explosions, scattering newly formed elements into space. These stellar explosions are among the most energetic events in the universe, outshining entire galaxies for a brief period. Less massive stars, like our Sun, live much longer, steadily fusing hydrogen into helium for billions of years. As they cool and shed their outer layers, they leave behind a dense core known as a white dwarf, which slowly fades over billions of years. The universe is teeming with a diverse array of stars, each with its own unique characteristics. Astronomers classify stars based on their temperature, luminosity, and size, creating a celestial zoo of stellar objects. The most common type of star is the red dwarf. These small, cool stars are much fainter and less massive than our Sun. Despite their dimness, red dwarfs are incredibly long-lived, with lifespans stretching into trillions of years. Because they're so common, red dwarfs are thought to host a significant fraction of the planets in the Milky Way. Moving up the stellar ladder, we encounter yellow dwarfs, like our Sun. These stars are hotter and more massive than red dwarfs, with lifespans of around 10 billion years. Yellow dwarfs are relatively stable and provide the ideal conditions for planets like Earth to form and support life. At the higher end of the mass spectrum, we find giant and supergiant stars. These stellar behemoths are much larger and more luminous than our Sun, but they live much shorter lives. Blue giants, for example, burn through their fuel quickly, often ending their lives in spectacular supernova explosions. Neutron stars are the incredibly dense remnants of supernova explosions, while pulsars are rapidly rotating neutron stars that emit beams of radiation. Black holes, the most extreme objects in the universe, are formed when massive stars collapse under their own gravity, creating regions of spacetime where gravity is so strong that nothing, not even light, can escape. Our Sun, a seemingly unremarkable yellow dwarf star, is anything but ordinary. It is the center of our solar system, the source of light and heat that sustains all life on Earth. Without the Sun's energy, our planet would be a frozen, lifeless wasteland. The Sun is composed mostly of hydrogen and helium, the two lightest elements in the universe. Deep within its core, under immense pressure and temperatures of millions of degrees, hydrogen atoms are constantly fusing to form helium, releasing a tremendous amount of energy in the process. This energy, in the form of light and heat, radiates outwards from the Sun's core, eventually reaching Earth and the other planets. The Sun is not a static object. It is constantly churning and erupting, with vast streams of charged particles, known as the solar wind, flowing outwards into space. These solar storms can disrupt satellites, interfere with communication systems, and even cause power outages on Earth. Despite its power, the Sun is a relatively small and average star. It lies roughly halfway through its estimated 10 billion year lifespan, meaning it has about 5 billion years left to shine. Eventually, it will exhaust the hydrogen fuel in its core and begin to expand, transforming into a red giant star that will engulf the inner planets, including Earth. Planetary formation from dust to worlds. Planets, unlike stars, do not shine with their own light. They are celestial bodies that orbit stars, reflecting the light of their parent star. The formation of planets begins in the swirling disks of gas and dust that surround young stars. These disks, known as protoplanetary disks, are remnants of the same material that formed the star itself. Within these disks, tiny grains of dust and ice collide and stick together, gradually growing larger over time. This process, known as accretion, is similar to how dust bunnies form under your bed, but on a much grander scale. As these planetesimals grow larger, their gravity begins to attract more and more material, eventually clearing out a path in the protoplanetary disk. Over millions of years, these planetesimals can evolve into full-fledged planets, their composition and characteristics influenced by their distance from the star and the materials available in the disk. The inner regions of protoplanetary disks are hotter than the outer regions, so only rocky materials like iron and silicates can condense into solid form. Diverse planets, a tapestry of worlds. Our solar system is a diverse collection of planets, each with its own unique characteristics and beauty. From the scorching heat of Venus to the frigid plains of Mars, from the swirling storms of Jupiter to the icy rings of Saturn, our solar system is a testament to the incredible variety of worlds that can exist in the universe. Mercury, the smallest planet in our solar system, is a world of extremes. It is tidally locked to the Sun, meaning one side always faces the Sun, while the other side is perpetually dark. Venus, often called Earth's twin due to its similar size and mass, is a cautionary tale of a runaway greenhouse effect. Its thick atmosphere traps heat, making Venus the hottest planet in our solar system. Mars, the red planet, has long captured our imagination as a potential abode for life. While Mars is a cold and dry desert today, there's evidence that it may have been a warmer, wetter world in the past. Jupiter, the largest planet in our solar system, is a gas giant with a swirling atmosphere of hydrogen and helium. Its iconic Great Red Spot is a massive storm system that has been raging for centuries. Jupiter has over 70 known moons, some of which, like Europa and Ganymede, are thought to harbor vast oceans of liquid water beneath their icy surfaces. Saturn, with its stunning rings, is another gas giant, known for its beauty and complexity. Our pale blue dot, Earth's place in the cosmos. From the vastness of space, Earth appears as a pale blue dot, a tiny oasis of life in the cosmic void. It is the only known planet in our solar system, and perhaps the entire universe that harbors life. Located in the habitable zone, also known as the Goldilocks zone, Earth receives just the right amount of solar energy to maintain liquid water on its surface, a crucial ingredient for life as we know it. Earth's atmosphere also plays a vital role in supporting life. Composed primarily of nitrogen and oxygen, our atmosphere acts as a protective blanket, shielding us from harmful radiation from the sun and regulating Earth's temperature. The presence of liquid water, a stable atmosphere, and a protective magnetic field all contribute to Earth's habitability. Over billions of years, life has profoundly shaped Earth's environment, transforming its atmosphere, oceans, and land masses. The oxygen we breathe, for example, is a byproduct of photosynthesis, a process that evolved in early microorganisms. Section 8, Exoplanets, worlds beyond our solar system. For centuries, humans wondered if there were other planets beyond our solar system, orbiting distant stars. It wasn't until the late 20th century that astronomers developed the technology to detect these so-called exoplanets, opening up a new era of discovery and expanding our view of the cosmos. The first exoplanet orbiting a Sun-like star, 51 Pegasi b, was discovered in 1995. Since then, astronomers have detected thousands of exoplanets using a variety of techniques, including the transit method, which looks for dips in a star's brightness as a planet passes in front of it, and the radial velocity method, which detects the wobble of a star caused by the gravitational pull of an orbiting planet. The diversity of exoplanets discovered is astounding. From hot Jupiters, gas giants that orbit incredibly close to their stars, to super-Earths, rocky planets larger than Earth but smaller than Neptune, exoplanets have challenged our assumptions about planetary systems and expanded our understanding of the possibilities. Some exoplanets even reside in the habitable zones of their stars, suggesting the potential for liquid water on their surfaces, and perhaps even life. Section 9. The search for life. Are we alone? The search for life beyond Earth is one of the most profound quests in science. The discovery of even a single microbe on another planet would revolutionize our understanding of life in the universe and our place within it. One approach is to look for biosignatures, chemical or physical markers that could indicate the presence of life. These biosignatures could include the presence of certain gases in a planet's atmosphere, such as oxygen, methane, or ozone, or evidence of organic molecules on its surface. Another approach is to search for technosignatures, signs of advanced alien civilizations. These technosignatures could include radio signals, laser emissions, or even megastructures, such as Dyson spheres, hypothetical structures built around stars to harness their energy. While we have yet to find conclusive evidence of life beyond Earth, the search continues with renewed vigor. New telescopes, both on the ground and in space, are being built with the sensitivity to detect fainter and fainter biosignatures and technosignatures. Section 10. Unraveling the mysteries. The importance of space exploration. Space exploration is more than just a quest for knowledge. It's an investment in our future. By studying the universe and its celestial bodies, we gain a deeper understanding of our own planet, its history, and the forces that shape our world. Space exploration has also led to countless technological advancements that have benefited humanity in numerous ways. From satellite communication and GPS navigation to medical imaging and weather forecasting, the technologies developed for space exploration have found their way into our everyday lives. Moreover, space exploration inspires future generations to pursue careers in science, technology, engineering, and mathematics, STEM, fostering innovation and pushing the boundaries of human ingenuity. As we continue to explore the cosmos, we can expect to make even more groundbreaking discoveries that will challenge our assumptions, expand our knowledge, and inspire us to dream big. Section 11. Our cosmic connection. A sense of awe and perspective. Gazing up at the night sky, filled with countless stars and distant galaxies, evokes a sense of awe and wonder that few other experiences can match. It reminds us of the vastness of the universe and the incredible journey that led to our existence on this pale blue dot. We are all made of star stuff, the remnants of ancient stars that exploded billions of years ago, scattering the elements that make up our bodies, our planet, and everything we see around us. This cosmic connection links us to the universe in a profound way, reminding us that we are not isolated beings, but part of something much grander than ourselves. Understanding our place in the universe can also provide a sense of perspective. Our daily worries and concerns can seem insignificant when compared to the vastness of space and the timescales of cosmic events. This cosmic perspective can be both humbling and liberating, encouraging us to live our lives with a greater sense of purpose and appreciation for the preciousness of our existence. The universe is our ultimate frontier, and its exploration is a journey that will continue to inspire and challenge us for generations to come.